Dectura is the first end-to-end digital workflow for leather. From defect detection and mapping to nesting and cutting, combining 3 best-in-class technologies into a single integrated workflow. MindHive Finish Select is an AI-powered quality assessment system that automatically detects and maps defects with precision down to 0.17mm and processing of hides in just 15 seconds. It combines rule-based grading and qualification, which is customer-specific and configurable, giving easy access to production data. Mind an advanced nesting software that utilizes the defect data to optimize pattern placement, maximize material utilization, and ensures quality requirements are adhered to. Zünd digital cutting systems offer precision digital cutting that executes optimized cutting plans with perfect accuracy while eliminating manual marking and post-cut cleaning, with projection systems guiding the operator for pickup and kitting. This integrated approach delivers substantially greater value than implementing separate solutions, creating a truly transformative digital leather processing platform. Dectura dramatically improves quality consistency, material utilization, and yields through a large part-first algorithm and reduces rejects by up to 90% through optimized material nesting and cutting. So let me hand over to Dion from MindHive to explain a little more.
Hi, I'm Dion. I'm the founder and the CTO of MindHive Global, and as part of the Dectura workflow, we're responsible for the MindHive Finish Select system. This machine here to my left, and we'll talk a little bit about what it consists of and what its purpose is as part of this wider workflow. So we at MindHive specialize in building large neural networks specifically for analyzing complicated machine vision applications. In this particular case, we are processing complex hides, ready for the cutting workflow, and providing a full imaging and AI-backed analysis process that allows us to capture, map, and then pass on key information about the defects that otherwise might affect the cutting process. So today I'm going to tell you a little bit about the machine, what it's built of, kind of why it matters, what its key features are, and then we'll do a walkthrough of the workflow and give you a bit of an understanding of what to expect if you come and see one of these machines in action. So this machine here, we're at Zünd in Switzerland, is set up like you would have in any other production environment. The system's relatively simple. It consists of a large format camera array. So we have a very high resolution line scanning system specifically set up to image material of this size and of this complexity. We scaled it and designed it to target defects down to well into the sub-millimeter level, so that we can get a key understanding of tiny defects right the way up to macro hide level defects and map them accordingly ahead of cutting. So as it's configured, this system is set up with a 24-inch touchscreen, which gives us a nice, robust industrial user interface. We have a very rigid line scan system, a line scan camera array hidden underneath this big black hood over here, and a very specific or application-specific lighting structure. So we've designed our lighting to very carefully illuminate all of the tiny defects on these hides to give us the best possible chance of detecting and accurately cataloging small three-dimensional defects, things like tiny tick bites, hair follicles, right the way up to scratches and other macro-level defects. The process for running the system is very, very straightforward. In a production environment, it'll be more or less exactly as we have it set up now. Operators load the hide inline. It's an inline process that we don't stop the product, we do it all in motion. From this end, we feed hides in. We can use whatever unique identifier you have. In this case, we're applying a QR code that just gives us some way of tracking the data against the material, but we can use tannery labels or any other sort of cutting house labels that you might apply. Operators simply load the hides here, one at a time in production. We run at about 15 seconds per hide, a speed that roughly fits just how good humans can be when it comes to placing the hide and having it nice and flat. As it passes under the camera array and the lighting system, we image it at super high resolution, producing a very, very high resolution set of images that we then process through an on-site neural network processor. Normally sitting in an IT room or a nice server room, here you'll see it as we walk past. It's just sitting next to the machine. All of that information is processed in real time because it has to be. We don't have time to send this information to the cloud. The amount of information we produce and image data we produce is huge. So it's processed in real time on premise. We provide all the analysis, which then is then fed directly into the DXF generation process, and then on into downstream nesting and cutting. So what we'll do right now is run this hide that we've just laid here ready to go through the process. We'll give you an indication of approximate real-time operation. Again, this machine's running a little bit slower because it's in a demo environment. We need to allow people to play with it a little bit more. But in a production environment, you'd see this operating at about 15 seconds per hide, 4 hides per minute. Just for comparison, that means we're running upwards of 1,200 hides in an 8-hour shift, including breaks. There's a target that our existing customers are hitting quite comfortably. By comparison, a human would be between 7 and 20 minutes to mark up a hide like this. This particular one is a semi-aniline hide with a lot of very complicated inherent defects. So our operation speed is obviously vastly superior to humans, and we'll get into the accuracy and what we can detect as we get to the other side. It'll make more sense there. So we'll start the conveyor up. Very straightforward process. Hides will just run all day, every day. There isn't a requirement for operators to really do anything other than load the hide and then read the information at the other end. So walking through the process, you can see the hide moving through the conveyor. Very, very straightforward. That's all the interaction operators must have with it. Passes underneath the cameras and the lights. We have a deionizing bar. We have a little bit of air moving just to knock off any top dust. But we can differentiate between loose dust and dust trapped under a top coat for the purposes of contamination. This is the processor stack. As mentioned before, typically this sits within an IT environment, but for here, we have it sitting here today. We'll just pause the conveyor for now for the purposes of the demo. Again, in production, this is a fully inline process. There's no requirement to stop the product. The output is, some type of display. In this case, we have a large one. Doesn't really matter. It's typically one of the other displays you saw at the other end of the machine. And we'll walk around here and have a little bit of a look at what we see, and we'll explain what's important. So now we're on the back side of the machine and you've seen the process from start to finish in real time. We can talk a little bit about what we see and what we show to the operators at the back side of the process, which is also sort of a really good understanding of what's going on behind the scenes. So once the hide's processed, we are showing our operators some key information about what to do with the product. Now, typically that's just a grade. So operators that are unloading these hides are not typically graders themselves. They're not the ones that would otherwise be doing the defect detection. And we are telling them what to do with it in a standard logistics process. And for most of our customers, we're ingesting all of their product as it comes in one big logistics flow. Again, given our speed, we can comfortably hit 1,200 plus hides in an 8-hour shift, which obviously drastically outperforms humans that are between 7 and 20 minutes for this sort of product. The output display gives operators an understanding about what to do with the product. So we have multiple selections that we can display, and we can do coarse grading. So that allows us to determine what the best fit for this product would be as far as what a customer's rules are. So in this case, we've just placed some panels, and the panels are placed based on what customers have given us as a criteria for how they might their grading. This draws on our extensive background of grading hides in wet blue in the wet blue production environment. We were doing this to about 1 million hides a month at the moment. So customers have full flexibility on what their course selection criteria are. Bear in mind, this has absolutely no bearing on downstream nesting. We're not aware of what's going to be cut yet. We're just helping operators sort these into A, B, C, D, E categories. On the screen, you can see what we saw on this particular hide. The model running on this machine at the moment is doing about 20 defects, different defect classes. We're adding to them all the time as we gather more data and we get more feedback from customers. We rapidly add and ingest new data training material, which allows us to add new defect categories super quickly. So we won't go into the deep details here, but to summarize, we can see things like hole. Obviously, we see insect bites down to very, very small and very shallow bites. Again, at the request of our customers, we have 3 different types of scratches currently loading in this model. So we have flat, ditched, and raised scratches. We can see contamination. That's things that are stuck under top coat. This is different from dust that's just sitting on the hide. We know the difference, and the system can tell the difference. We can do subsurface defects, like where we expect grain damage to pop through. We do neck wrinkle. We're doing pleats. We do loose grain and heavy grain, and we can tell the difference between grain that will delaminate versus grain that's just visually different from the rest of the hide. We do rough grain, so that's where you might get bacterial damage. We see that often on the spine of the animals, sort of rough patches that are not cuttable but aren't necessarily related to looseness. We do color change. That's where you might have a process problem where you've got misapplication of color. We can tell the difference between creasing and pleats. So pleats are where the product's been ironed. Creases might be where it's been stored funny and you've got a permanent crease. We do warts. We do toggles. Toggles are where the hide's been stretched. These are all non-cuttable defects. And we can do veins. There's a whole lot more detail you can go into looking at our defect catalog, which is available on request. It's constantly being updated as we add new defects, 1 or 2 a month. So operators get to see all this information. They don't necessarily have to act on it. It's just helpful debug. Most of the time, they will then just place it on a horse. So that's, I guess, sort of gives you a bit of an understanding of the entire logistics workflow. What's key about what happens after this is that we pass all of this data, all of the defect information gets bussed up to the cloud. We will then generate a DXF that's specific for the cutting application required. We don't dumb it down. We don't provide quality zones. We're not doing anything to condemn pieces of the hide. We are passing that data in a very raw state downstream to the next stage, which typically in the Dectura workflow is the mine nesting process. We'll let them get into that, but it's crucial to understand that our data is at the rawest possible level, at the highest resolution we can provide it. And that gives downstream nesting and logistics and product data management the best possible chance of understanding the best possible use case for each hide. It's a lot of information, and the workflow and the work stream that processes down through to cutting is optimized to deal with this unusually large quantity of data, but it means we can fully leverage all the information we produce. So from here on, I'm going to pass you on to Mind, and they'll talk to you all about how their process works and how they further leverage this information to get the best possible outcome.
Thank you, Dion. I'm Ricardo Carranga from Mind, the R&D or Software Development Director at Mind. And I'm here to explain you what we do after scanning the hides in the MineHive Finish Select. So out of the MineHive Finish Select, we receive a file with lots of information, geometrical information, classified by layers about what kind of defect it is, if it is an insect bite, if it is a scar, loose grain, whatever it is. But then we need to give it some operational meaning. So we need to transform those artifacts into either defects or quality areas. Then we cluster all this kind of information, and for instance, in a certain area, if we have more than 5 scars, then those 5 scars are, for instance, quality 4. Or we have a loose grain area bigger than a certain amount, then it is quality 5. And we can set up all these rules in this NFG configurator, and then once you are happy with the rules, you save it, and every hide that is digitized through the MineHive Finish Select, they go directly in a transparent way into the server. They are automatically classified and ready to be used. And then, once we are ready, it is the moment to gather this with the production information. And for this, we can connect to the ERP system and to collect the cut orders. And the cut orders, they have the information of which materials to produce in which quantities. Together with the materials that we have to use, then we have a nesting job. And what does this nesting job do? It combines everything. So in a powerful nesting server, what it will do is that it will pick the parts and try to nest with the best material utilization possible. So the best efficiency we can get, and it can run overnight to achieve really the best results. So the better the results, the more savings you will get. And what will happen in this nesting process is that it will place the parts respecting the quality areas that are marked on the parts on the hides, also respecting the quality areas that were previously identified from the digitized materials from MineHive Finish Select. And the biggest advantage of doing this offline and knowing all the hides you have to produce this cut order is that you take the advantage of having a kind of a big material that is composed by all the separate hides, and then you do a multi-hide nesting. Once we are happy with this result, we can publish it, and then we will cut it in the Zünd machine. But that part, I will leave that up to Catherine to explain you how to do it.
Thank you, Ricardo. I'm Catherine, Global Market Manager for Furniture, Fashion and Outdoor here at Zünd headquarters in Switzerland. And our cutter is the third part of the Dectura workflow solution. What you see here is our D3 double beam cutter, 2XL 3200 with a back and front extension. But all cutters of our portfolio are available for the Dectura workflow. The hide, which has previously been scanned on the MineHive Finish Select table and has been nested with the Mind software, is now ready to be cut. First of all, the hide is placed on the back extension of the cutter. We are then reading the barcode and call the nesting job. We take a picture of the boundary of the height, and then the nesting job is automatically aligned with the physical height. This step is crucial and accuracy is key, as we have to avoid that the nested parts are slipping in a defect area of the height where they are not allowed to go to. Once this is done, the vacuum is turning on and the height is transferred to the cutting area. The cutter has 3 slots for different modules. So according to the customer requirements, there can be different cutting tools. You can choose different tools for cutting, but also notching, punching, or marking. While this height is cut, we can already proceed with aligning the next one on the back extension. Once the cutting process is finished, the vacuum is released and the height transferred to the pickup area, which is the front extension of the D3 cutter. For sorting, you have the help of the projectors, the TV screen, or both of them. Sorting can be done according to kits, groups, sizes, or whatever is required by the customer. Yeah, that's it. The Dectura workflow is finished here, and you should have perfectly cut parts according to your requirements.
Dectura combines 3 world-class technologies, giving our customers perfect cut parts and improved and optimized yields repeatedly, processing every hide to the exact NFG and making multi-hide optimization a reality. Dectura will revolutionize your entire leather processing workflow with a seamlessly integrated system that combines AI-driven defect detection, intelligent nesting algorithms, and precision digital cutting. This comprehensive approach improves yield, eliminates post-cut cleaning, reduces labor, and ensures consistent quality, even with the most demanding of customers. I truly hope that we've captured your interest, and please do contact us and come and see the solution in action.